in this video we're going to look at solving exponential equations, which essentially just means, which I can't spell for whatever reason, which essentially just means we're going to have an exponent somewhere in our problem, and our job is to figure out what that exponent's going to be. Well, I'll explain it like this. Our variable, like say we have x as our variable, it's going to actually be in the exponent. All right, so x will be in the exponent, and our job is to solve the problem. Now, there's two types. We're going to start off with type 1, which the first type is when you have a common base. Okay, so the base of the exponent will be the same, and it would look like this. I'll give you an example, and then we'll kind of go from there. So 2 to the x plus 1 equals 2 to the 9th. So our job is to solve this for x. Okay. Now, the reason this is a common base or type 1 situation is because on both sides of the equal sign, the base of our exponents, which is 2 and 2, obviously are the exact same. So when that happens, so if you have the same base on both sides, there's actually an easy way you can deal with this. The bases just cancel. So you bring down whatever your exponent is and say x plus 1 equals 9, and then we can solve that equation. So we would subtract 1, subtract 1. I'll do this part pretty quick. So x equals 8. All right, let's look at another example, and I bet you could probably work this one. So why don't you give it a shot? Let's say we have 5 to the 4x plus 5 equals 5 to the x minus 7. So once again, try this one on your own, but our job is to solve for x. All right, so now, this is a type 1 situation for this solving exponential equations, because once again, the base of our exponents are both 5. And if that happens, the good thing for you is you can just cancel the bases. So then 4x plus 5 is going to equal x minus 7. So now we're just going to solve this equation, which I'll do it pretty quick. I've previously uploaded videos on how to solve equations, so be sure to check that out if you need some extra help solving equations. So 3x equals, because we'll subtract x to this side over here, we'll subtract 5 to this side over here, so 3x equals negative 12. So x is going to equal, should be negative 4, I believe. All right, so hopefully that was easy enough thus far. So now here's another example that you can get into with a common base. So we're still on the common base type of problem. We have 3 to the k times 3 to the k plus 2 equals 3 to the k, well, 5k minus 1. So once again, the question you want to ask yourself is, okay, I have an exponent as my variable, or my variable is an exponent. So then you want to ask yourself, okay, how am I going to go about getting rid of my bases? Well, my bases are all the same. So we just got through saying we could just cancel those bases. Now, here's the part where I hope you have a question. I hope the question is, okay, we bring down k plus 2, and that's equal to 5k minus 1. I hope your question is, well, what's happening in between this k that we brought down here and k plus 2? Well, if we go back to rules for exponents, when we're multiplying two bases and we have exponents, hopefully we remember that we add the exponents. So we are going to add here. All right, so if you have multiple bases and you're multiplying those bases, you can still drop your bases and cancel those, but then you have to add what you have left over. Okay, so now this would be 2k plus 2 equals 5k minus 1. And once again, I'm going to kind of speed through this part to try to make the video easier to watch. But once again, I've uploaded videos on two-step equations, and this would actually be a multi-step equation. So check those out if you need it. Let's see, I would subtract 5k here to get rid of this. I would subtract 2 here to get rid of this. So we've got negative 3k equals, that would be negative 3. So then we're going to divide both sides by negative 3. And that should give us 1, I believe. Let me write it out just to make sure. Yep, k is going to equal 1. So there's our answer. Now, you could go back and check these answers, but I'm not going to do that. I would assume most of you probably don't check your answers. All right, so how about we try one more of those, and then we're going to get into some more difficult problems, okay? So I would suggest you, once again, try this one on your own. So 10 to the negative 4 times 10 to the 9th equals 10 to the v plus 4 times 10 to the 2v minus 11. All right, so try this one on your own. Once again, our bases are the exact same, so all these 10s go away. They're going to cancel, okay? However, we just have to remember, since we're multiplying, we're going to add these exponents. So we're going to say negative 4 plus 9, and on the right side, we're going to say v plus 4 plus 2v minus 11. So we're not going to multiply these, okay? That's the biggest mistake, or the most commonly made mistake that I see. So 5, let's see, negative 4 plus 9 is 5. Let's combine our like terms. A v and a 2v can add, that's 3v, not 2v. My bad. All right, 3v. And then a 4 minus 11 would be negative 7. All right, so 5 equals 3v minus 7, and now we can just solve this. This is just a two-step equation. So let's add 7. Let's add 7. 12 equals 3v, so v is going to equal 4 when we divide by 3 on both sides. All right, so now that takes care of the common base examples. So now let's talk about type 2, because I'm sure you've been thinking, well, what's the second type? And that's when we have an uncommon base. Basically, the bases are not the same, okay? So an uncommon base. So let me give you an example of what that looks like. And for this video, I think I'll try to stick with more basic examples. You can almost make this as hard as you want or as easy as you want. It's just one of those things. All right, so 6 to the 2x minus 10 equals 36. So now, when we did the previous problems, we said, okay, when the bases are the same, the bases cancel. But obviously, 6 and 36 are not the same. So you obviously can't just cancel 36 and 6. However, if we could somehow write 36 so that it has a base of 6, then we could actually do that. So pretty much your uncommon base problems, your goal is to create or make common bases. So I'll even say it this way so it's more clear. So make bases the same. So our goal is to turn it into a type 1. So it essentially begins type 2. We turn it into type 1 so that we can solve it. All right? So how do we do that? Well, you have to be pretty decent with your exponents here or have a good understanding of exponents, but I'll draw it out for you so you can see. But it'll be one of those things that you have to practice and you'll get better at it as you go. So I want to make 36 have a base of 6. So it has a base of 6, but I still need to get 36. I can't just get rid of 36. I need 36, and if 6 is a base, I need to have an exponent. So right now I'll just write it as x, or actually I'll just write it as a question mark. 6 to the what power is 36? That's the question you're going to ask yourself. All right? So hopefully you're going to say 6 to the second power is 36. So now if I get rid of this 36, and I rewrite this, 6 to the 2x minus 10 equals 6 to the second power. Now this looks exactly like the first few problems. This would now be a type 1 equation. So we would cancel our 6's. 2x minus 10 is going to equal 2. And now we can just solve this equation, which I'll do it quick. Plus 10 plus 10. Let's see, 2x equals 12. So x will equal 6. All right, so let's look at another one, and I bet you will be able to do this one. So why don't you try it? Let's say I gave you 2 to the p minus 7 equals 8. So try this one. Now, if you're stuck, here's the first question you ask yourself. Can I cancel the bases? Well, no, because 2 and 8 are not the same base. However, you want to ask yourself, could I take the bigger number, which is 8, and make it a base 2 to a power? So you're really asking yourself, okay, 2 to the what power is 8? And we could actually do this. 2 to the third power is 8. So now we can say 2 to the p minus 7 equals 2 to the third. And now we just turn this into a type 1, so the bases cancel. P minus 7 equals 3. So then we would add 7, and p equals 10. So hopefully that was easy enough. Let's try, I'm going to try to make one, or try to find one that's a bit more advanced, just so you can see it. Let's see. How about we try, we'll get majorly advanced, and we'll see how we do. All right. Let's say I gave you 4 to the y plus 2 equals 16 to the y minus 3. Now, in the type 2 examples, we haven't seen one like this yet because I've yet to give you an exponent on both sides. However, we can still go about this the same exact way we've been doing it. First of all, the question you're going to ask yourself is, are these bases the same? And they're not. One is 4, one is 16. However, you want to take the bigger number, which is 16, and you want to ask yourself, okay, could I make 16 into a base of 4 set to a power? So what would this power have to be in order to get back to 16? Well, I think we can all do that. It would be 4 to the second power. So now let's see what happens when we rewrite this. 4 to the y plus 2 equals 4 squared, and that's all to the y minus 3. So now I'm hoping your question is this, because we can cancel these 4s. I hope your question is, well, what's happening between 2 and the exponent that was already there? And for that, once again, we're going to need to review our exponent rules. If I gave you x to the second power raised to the third power, hopefully we remember what we do with an exponent raised to a power. So 2 and 3, what happens there? Well, we're going to multiply. So this would give me not y, it would give me x to the 6th. So that tells us, if we apply this same logic or this same concept to this problem, we're going to multiply 2 by y minus 3. So it would look like this. Y plus 2 equals 2 parentheses, because we're multiplying, y minus 3. So hopefully now you can see we're going to have to distribute this to. And I'll just be honest with you, the example we're doing right now is it's where most of the mistakes happen when people make mistakes. Okay, so what I would suggest you do is even rewrite this down and try it on your own, just so you can spot this part of the problem. You have to make sure you know when there's a power set to a power, which is what happens with 2 and y minus 3, we have to multiply those. All right, so now I'm going to start a new page just so we can finish this problem. So we said it was y plus 2 equals 2 times y minus 3. So now we're just going to solve this equation. Y plus 2 equals 2y minus 6, because we distribute. When we put, please go away, when we put our y's on the same side, let's see, I would subtract 2y over here, and I would subtract this 2 over here. Once again, I have videos on multi-step equations, so be sure to check those out if you're struggling with any of this. So let's see, negative y equals negative 8. So now we need to get rid of this negative, so we would divide by negative 1. Y is equal to 8. All right, so that would be our answer. Now, let's make this even a little bit more complex, and maybe we'll do like 1 or 2 more examples. But Actually, let's try one that's similar to this. I don't want to go too fast. All right, so I'm going to give you one that's similar to this, and I want you to try it. So 27 to the 2x plus 6 equals 3 to the 2x. Once again, try this one and see if you can figure out the answer. All right, so first thing is, obviously the bases aren't the same. One's 27 and one's 3. So your job is to try to make the bigger number, which is 27, have a base 3. So it would be 3 to the what power is 27? Well, that would be 3 to the third power, I believe. Yep. All right, but then that's all still to the power of 2x plus 6. And then it's equal to 3 to the 2x. So now my question to you is, okay, I'm going to cancel these bases, but what happens between this 3 and 2x plus 6? Hopefully we remember, since it's a power to a power, they get multiplied. So it's 3 times 2x plus 6 equals 2x. And now we can just solve this equation. So once again, I'm going to get rid of this. 3 times 2x plus 6 equals, I think we said it was 2x. Let me double check. Yep. All right, so now let's solve this equation. So once again, we're going to distribute 6x plus 18 equals 2x. This is a rare case where I actually move the x's over here. But I would subtract 6x, subtract 6x. 18 equals, let's see, what is that? Negative 4x. So this is going to give us a fraction or a decimal as our answer, but that's fine. Divide by negative 4, divide by negative 4, and x is going to equal, let's see, when we reduce this, it would be 9, negative 9 over 2, or I guess you could write it as 4.5 if you'd like. All right, so now let's do one more, just so you can see. I would consider this one of the more complex problems, maybe not the most complex, but it is pretty difficult for a lot of people starting out to do. So let's see if you can do it. 16 to the 3x equals 8 to the x plus 2. So give it a shot. So if you gave it a shot and got stuck, I can almost guarantee you where you got stuck. So we want to look at the bases, and first of all, they're not the same, so we can't just cancel 16 and 8. But then remember, we always take the bigger number, and we try to make the bigger number, or thus far we've made the bigger number, the smaller number, or we've used the smaller number to make the bigger number break down. Okay, took me a while to get there, but I got there. All right, so 8 to the what gives me 16. Well, let's just think about it for a second. 8 to the first power would be 8, but then 8 to the second power is 64. We just skipped right over 16. So this is a rare case, or may not be all that rare, but this is a case of where we're actually going to have to break down both numbers. So you have to think about, okay, what could I do with 16 and 8? What base could I use that would still give me an exponent that could get back to 16 and to 8? Well, let's try 4. We know 4 squared is 16, but is there a way to write 4 to a power to get to 8? I can't think of one because we just used 2 and we already skipped over 8, and then 4 to the first power is just 4, so let's go down lower. Let's try 2. So 2 to the what power gives us 16? Well, that's 2 to the fourth power. Could we write 2 to a power to get to 8? Yeah, we could. We could write that as 2 to the third power. So that's actually how we're going to break each of these down. So this is our new base, 2 to the third, 2 to the fourth. And now we still have 3x here, and we have x plus 2 here. So now we're good to cancel these 2's, but you have to remember a power to a power is going to get multiplied, so 12x is going to equal 3 times x plus 2. So once again, it's a difficult problem for people to do at the beginning, but as you practice it and after you see it especially, you start to understand why we had to use 2 as our base as opposed to like 4 or 8. All right, so now let's finish this one off. 12x let's see, 12x. 12x equals, where am I? 3x plus 6, or actually 3 times x plus 2. I got one step ahead. All right, so now we're going to distribute this right side. Now we need to move our x's to one side. Subtract the 3x over here. It'll go away here. And that would give us, let's see, 9x equals 6. And we're going to have another fraction, which is fine. So now we would divide by 9. Divide by 9. X is going to equal, let's see, 6 over 9 would reduce to 2 over 3. So that would be our answer. So once again, this video is going to cover type 1 common base examples and type 2 uncommon base examples. But honestly, when you have, let me get rid of this. When you have a type 2, essentially, once you make the common base, so you'll make the, we'll just say make bases the same. Once you make the bases the same, it turns into a type 1. So you make the bases the same, and then it just becomes a type 1 problem where you can cancel your bases, and that's the whole point of getting the bases the same. So if this video helped you, feel free to share it with somebody. Feel free to like, subscribe, whatever you need to do, but that will be it for this video.